Okay, today we'll be expanding on our discussion of stoichiometry. And so we looked at mole to mole conversions, looking at the mole ratios from balanced equations. Now we're going to extend on that, and we're going to take a look at mass to mass conversions. If you remember from our prior discussion, we were looking at a compound, and we might have a mass of a compound, and then we wanted to determine what's the mass of an element inside of that compound. And so we took the compound mass, then we multiplied by the molar mass, we used the mole ratio, and then we multiplied by the molar mass of the element to get, for example, if we had 16 grams of carbon dioxide, then we would have 4.4 grams of carbon inside of that 16 grams. The same thing will be true whenever we look at balanced equations. And so the generic way that we would look at this, or the general framework, is that we'd start with whatever we have for A. So we'd have mass A, and we would be looking at that. And then using our molar mass, we would be able to get to the moles of A. Then we use the ratio that we get from our balanced equation to convert to moles of B. And then if we want that in mass, in grams, then we just use the molar mass to get to the mass of B. So this is very similar to what we've done before whenever we're just looking at a compound, except that now our mole ratio from the balance is coming from the balanced equation rather than just from the formula. So let's just go ahead and jump into some examples. So if we are looking at this example, we're looking at combustion. And first, let's just go ahead and say, what is the mole ratio between the reactants and the products? And so if we're looking at mole ratios, I'm just going to go ahead and write it right below. So we would have 2 moles of C18H18, which is octane. We have 25 moles of oxygen. We have 16 moles of carbon dioxide, and we have 18 moles of H2O. And so we can use these relationships and our mole ratios in order to do our conversions. So let's go ahead and do that example. So above it says calculate the mass of CO2 that's emitted when we combust that many grams of octane. So we'll go ahead and start with our grams of octane. So 5.0 times 10 to the second grams of octane. And so our first step is going to be to convert that to moles. So we'll go ahead and we'll say, in this case, we have 1 mole of C8H18. The molar mass for this will be 114.3 grams of octane. Sorry, I keep switching back and forth, but that is the same thing. We then have 2 moles of C8H18 for every 16 moles of CO2. And so we get that from our balanced chemical equation. And then we'll use the molar mass of CO2, which is 44.01 grams of CO2 for 1 mole of CO2. And then we'll go ahead and multiply and divide as needed. So our grams of octane cancel out, our moles of octane cancel out, our moles of CO2 canceled out. We're left with grams of CO2. And this will give us 1.5 times 10 to the third grams of CO2. Let's jump into another example. Okay, so here's a balanced equation. You should remember this from your bio days, looking at photosynthesis and the conversion of carbon dioxide and water into glucose. So first, let's start with the mole ratio. So we have 6 moles of CO2 for every 6 moles of water, for every 6 moles of oxygen, for every 6 moles of glucose. Okay, let me go ahead and give you the molar masses for a few of these so that you can practice this on your own if you would like. So the molar mass of CO2, 44.01 grams per mole. And the molar mass of glucose is 180.2 grams per mole. So we're going to take a look at Then we're going to go ahead and use our mole ratio. So we would have 1 mole of magnesium hydroxide for every 2 moles of hydrochloric acid. And then we'll use our molar mass of hydrochloric acid, which is the 36.46 grams of hydrochloric acid is in 1 mole of hydrochloric acid. I'll make sure that my units cancel out. Multiply that across, and I would find that 6.88 grams of HCl can be neutralized. All right, for our last example, let's look at acid rain. And so we are looking at, if we have more than enough oxygen in water, how much sulfuric acid in kilograms forms from 2.6 times 10 to the third kilograms of sulfur dioxide. So sulfur dioxide, molar mass is 64.07 grams per mole. Sulfuric acid is 98.086 grams per mole. You can go ahead and pause and solve this on your own if you like.